I can't remember, one class we didn't finish problem number 4. Was that you guys?
Yes.
So we need to finish this problem. So I know we had gotten it started. And remember what was our objective with this great big huge problem? Our objective was to make all the denominators the same. So we did that. We went through, this one needed an x and an x plus 4. And this one needed just an x. And that one didn't need anything. And why do we care about the denominators all being the same? What good thing happens when the denominators are all the same? Then all we care about is the top, right? So this is what I have left on the top. Okay? Now, what would I do next? I don't remember where we got in this problem, so I'm just going to start here. What do we do now? What would I do next? Distribute. So this is going to be 2x times x. So that's 2x squared. And 2x times 4, that's 8x. Don't let that. 2x times x and 2x times 4. Minus 3x equals 12. Okay, then what? Combine those, right? So 2x squared plus 5x.
Subtract 12 to the outside.
Subtract the 12 over. Because what kind of an equation is this?
Quadratic.
Quadratic. And when we have quadratics, we want them set equal to 0. So that we can do what?
Factor.
What we just got done doing on the quiz you took, right? You have to factor. Oh, quote, by the way, what if it doesn't factor? Because not everything does. Then we'll use the quadratic formula, right? Could you use the quadratic formula anyway? Yes, but it always takes a lot longer. Factoring is always easier, and we need factoring practice anyway. So, since that's a 2x squared, this is going to be a 2x and an x. It has to be, right? So when you multiply, you get 2x squared. Now, I need factors of 12. Well, I have several choices, 12 and 1, 6 and 2, 4 and 3. All right, I'm going to go with 4 and 3. That's a minus 12. So that means these have to be one negative and one positive. I don't know which one, but it's got to have one of each, right? Now I'm going to check this. I don't think it's right, but it's my first guess, so I'm going to go ahead and check it. So 2x squared plus 3x minus 4x minus 12. That is not going to work because I need a 5. So I might change these two numbers and put the 3 here and the 4 here. That'll give me 2x squared plus 8x minus 3x minus 12. I think that works, doesn't it? So these are the correct factors. So that means the answers are 3 halves or negative 4. Right? Okay, I got bad news. There's one more thing to pay attention to. This is extraneous. The only answer to the problem is actually 3 halves. Because if you go back to the original problem and you put in negative 4, you gotta make 0 in the denominator, and that is never allowed. Okay? So you gotta remember, after you go through all this work, you gotta remember to go back and take a look at your answers. Do they fit in the problem? And as long as they don't make the denominator 0, it's okay. You don't have to check the whole thing and do all this, no. Just make sure they don't give you a 0 in the denominator. All right. All right, well, that was big. Let's look at the next one, number 5. How do you suggest you begin this problem?
Factor the last denominator.
Yeah, we should always factor. Hopefully what will happen is, when I factor that, I'll get these guys. That's a well-written problem when that happens, we hope that happens. So how does that factor?
Plus 4 minus 1.
Does this factor into x plus 4, x minus 1 by any chance?
Yeah.
That's really good news. Everybody okay at this point? You with me here? Okay. So what does this denominator need? If he's gonna match that,
It needs the
he needs an x minus 1. On the top and the bottom. What does this one need if he's gonna match? X plus 4 on the top and the bottom. Now, they all match. So forget them. I have 4x, x minus 1, plus 3, x plus 4, equal 15. As soon as the denominators match, you ditch them. All right, what do you want to do with this equation? So 4x squared minus 4x plus 3x plus 12, I'm distributing here too, also equals 15. Now let's do some cleanup work. So I got 4x squared minus x plus 12 equals 15. What about that? Move the 15 over. So 4x squared minus x minus 3. If I subtract 15. Now, this one also factors. I know some of you really struggle when you put a leading coefficient on there. But it does factor. On these problems, you can't always use the quadratic formula if that's easier for you. This factors because doesn't that give me 4x squared minus 4x plus 3x minus 3? Which is exactly what I wanted. But if you can't do that, then you'll have to use the quadratic formula to get your answers. You will get the same answers as I do, it'll just be more different work. So what do I come up with as my answers? What would this one be? X equals 1. Negative 3/4. You know what? If you can't do that in your head, by golly, write it down. Subtract 3. Divide by 4. Let's not mess around and put 4/3 because we're trying to do it in our head, because then you miss it. So do the work. Set it equal to 0 and solve it. Same thing with this one. X equals 1. Beep, 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 beep. Our little antennae are going up because tell me about 1. look back over here at the problem. Can x be 1? No, because if x were 1, that would be 3 over 0. And are you allowed to have 3 over 0? Never. So, guess what? That's extraneous, and the only answer is negative 3/4. Some students, when they get the original problem, actually after they factor it, but when they get the original problem, they'll look at it and say, right from the beginning, x can't be negative 4. Remember our domain stuff we did? X can't be negative 4, and x can't be 1. And they actually write that down at the beginning, so then when they get to the end, they can look back up here and say, oh yeah, there's a bad one, throw it out. You don't have to do that, but you do have to recognize that 1 won't work. Okay, these problems are big. Number 6. Here we go, number 6. Mr. Booker, what's the first thing I need to do with this problem? Do you think? Factor that denominator. That's the only thing that factors. So, when you say factor that, Xavier, the only thing I can do is take out an x, right? So I'll do that. I'll take out an x. And another beautifully rigged problem, because notice that those two are what we have in these other fractions. That's gonna make it easy. What does this one need? X plus 1, top and bottom. What does this one need? X, top and bottom. That one doesn't need anything. And since this is 0, it also doesn't need anything? Does that make sense to you, since it's 0?
0 divided by 2 is 0.
Yeah.
So.
Wouldn't matter what I put in the denominator, it's still gonna be 0. Okay, so I have x plus 1, x minus 3, minus 3x plus 3 equals 0. All right, let me make sure I got everything. So my denominators are gone. Okay. What do we do? Or a foil, that's a foil, or distribute, however you wanna call it. So we're gonna do x times x minus 3x plus 1x minus 3. That's first, outside, inside, last. And now minus 3x and plus 3. Alrighty, now we got a bunch of combining to do. What do we have? X squared.
Negative 5x.
Minus 3x.
So we got a minus 3 and a minus 3. That makes a negative 6. But we have a plus 1, so that'll be negative 5. I think I heard somebody say that. Negative 5x. And then,
Equals 0.
oh yeah, the 3's cancel, so that's what equals 0. That's an easy factoring. You will factor that, or use the quadratic formula, but I would factor it. Just take out an x. So what does that tell you? X equals 0, or x equals 5?
That's extraneous.
So look back at the problem. Can you put a 0 in right here, folks?
That would.
Nope. So the only answer to the problem is 5. why don't you take a minute, see if you can start it on your own. See what you can do with that last problem. Thinking about factoring that last denominator, and once again, it factored into the other two things you had. So, Jackson, what are you doing now? You did this, right? You got this factored right here? Okay, what are you doing now?
Adding the x plus 2 to the, or x minus 1 to the first one, and x plus 2 to the second.
Perfect. So all the denominators now match. So I can look at just the numerators. Everybody up to that point? That look okay? All right, Miss Plummer, what did you do next?
I don't remember what. I factored it in. Distributed. sorry.
Distributed it out, so you had 3x squared minus 3x plus 2x plus 4 equals 5.
Mhm.
So 3x squared minus x plus 4 equals 5.
Yeah. And then we subtract the 5 over.
So 3x squared minus x minus 1.
Equals 0.
Uh-oh.
That's where I stopped.
Yeah, that's where you stopped. Why'd she stop there?
This doesn't factor.
Because you can't factor it. Okay. What do we do when we can't factor? We're gonna use the quadratic formula. And what that means is no big deal, kids. It just means you're not gonna get answers like x equals 2. You're gonna get something like 2 plus or minus the square root of 7 over 9 or something like that, right? We're still gonna get answers. They just aren't gonna be nice. So here we go. X equals negative b will be positive 1 plus or minus the square root of b squared minus 4ac. All right, so where have I got? Everybody okay with this? Your numbers look like mine, I hope? A, B, and C, just plug and chug. So 1 plus or minus the square root of what?
11, 13.
13.
Wow.
That's gonna make a plus, folks. That's gonna make a plus. So 1 plus 12 is 13.
That doesn't factor.
2 negatives make an addition problem. And actually, I'm done, aren't I?
Yeah, 13 is fine, so.
Yeah, there's nothing I can do with that. So here are my answers. Now, don't panic. Don't be extraneous. Guys, what are the only 2 numbers that aren't gonna work in this problem? The answers that I would have to throw out would be positive 1 and negative 2. Did I get those? No, so I'm not worried about extraneous roots. I have weird looking roots, but that's what I get. That's what happens. Weird and factor. Okay? Now, that homework is gonna be due on, what's today,
Friday.
Wednesday? So we do Friday. And we're gonna go ahead and start the next section, but before the period's over, we're gonna get out our 2-7 homework, and we're gonna do one of the problems together. But first, we're gonna continue in our notes. So 2-7 is due on Friday. We're gonna get a couple of problems done in 2-8. All right, 2-8's a little bit longer, so I wanna get a head start on that, and then we'll do a couple. Okay, so here we go. Everybody's paying attention, and I promise, we'll get at least one of your homework, problems done. All right, here's the good news. It's already factored. This is 2-8, number 1. It's already factored. That's wonderful, especially for those of you that have to factor. What's different about this problem now? It's a less than. When you have a less than, I want you to do it on a number line. I want you to draw a number line. There are 2 parentheses in this problem. There are going to be 2 dots on that number line. Where do you think those 2 dots are going to be? At -2 and +3. I want you to look at these factors, look at where I put the dots. That's exactly what we've been doing all year long. When the factor is x plus 2, the 0 is -2, right? That's no different. Okay, now, notice those dots are open. Why are those dots open, do you think? Because it's not or equal to. If there were an or equal to on here, then I would color those dots in. They'd be right at the same place, I just color them in. All right? Frank, pick a number that's not -2 or 3, any other number.
5.
5. So Grant picked 5. 5 is out here on the number line. I'm gonna put 5 in. When I put 5 in, I get 7 times 2. That's 14. Is 14 less than 0?
No.
No. So I am not going to shade this in because it did not give me an acceptable answer. Do you remember our rule we talked about earlier in the year? That if this section is not going to be shaded, then what about this section?
That one is.
It is. And this one is not. They alternate, right? Now, we're gonna change that in a minute, but they will alternate in a basic problem like this. Just trust me. Answer then is the interval from -2 to 3. Those are parentheses because these are open. They would be brackets if those were closed dots. Okay? Now I want you to look at the next problem because it is not a nice, easy problem. This one is gonna involve a little bit more work. Will the dots be on the number line at the same places? Will they still be open? Yes. Can I still try 5 like you wanted to? Absolutely. Now, I'm gonna put 5 in, so I'm gonna get 7. 5 minus 3 is 2, but it's squared, so it's 4. So this time I got 28. It's still not less than 0, so I'm still not shading this part. Here's the problem. As soon as you put a squared in there like that, or any power, as soon as you put a power in there like that, you can't use your alternating rule. As long as there's no powers, they'll always alternate, no matter how many you have. You could have 10 dots, and they would alternate as long as you didn't have any powers on these. As soon as you put an exponent up there, then there's no more shortcut. We picked 5, it didn't work, so we didn't shade it, okay. Now I gotta pick a number in here. Well, what's the number in between there?
1.
1, so 1 would give me 3. Now be careful, 1 minus 3 is negative 2, but it's squared, so it's 4. Is 3 times 4 less than 0?
Nope.
No.
Not shading there either. Alright, pick a number out here.
Negative 3.
Negative 3. So negative 3 would give me negative 1. Negative 3 would give me negative 6. Squared is 36. Is negative 36 less than 0?
Yes.
So this worked. So this time my answer is negative infinity to negative 2. You can always try numbers in every section, but you only have to do it when you have a power in your problem. Okay? We're gonna do one more. We're gonna do number 3. Is number 3 gonna have dots in the same spot as the other 2 we've done? Yep. And they'll be open still. Am I gonna be able to use my every other rule?
Nope.
Nope. We're gonna have to check each section. So here we go. I'm just gonna stick with Grant's number 5. So if I put in 5, what's 5 plus 2? 7 squared is 49. 5 minus 3 is 2 squared is 4. I don't even need to work that out. Is 49 times 4 gonna be less than 0?
No.
No. What would we pick before, 1?
Yeah.
So 1 plus 2 squared is 9. Be careful here. 1 minus 3 is negative 2, but you're squaring it, so it's 4. 9 times 4 is not less than 0. Alright, negative 3 plus 2 is negative 1. Squared is 1. Negative 3 minus 3 squared is, wait, is that less than 0?
None of them work.
None of them work. So what's the answer to this question? No solution. There is no solution to that problem. Nothing got shaded in. All right, I'll stop there. And let's take a look at our homework, section 2-7. And let's do either 1, 2, or 3. Which one would you like to do together? 1, 2, or 3? 3? Alright, we'll do 3 together. So this is gonna be due Friday. You gotta get 2 I'm doing one of them for you, so you gotta get the other 2 done before Friday. Come on, people. I'm gonna go ahead and start this problem the way Xavier had us start the last one. I'm gonna go ahead and factor that last denominator. Does that make sense to you?
Yeah.
And again, luckily, because this is math class, not the real world, when I factored it, I got these 2 guys. Makes my life so much easier. All right. So, Quinn, what am I gonna do now? I factored this last guy. What am I gonna do now? You phoned a friend. He's trying to help you out. What do we need to do, gang? We need to make the denominators match, right? So Quinn, look, we're gonna make the denominators match. So for this one to match this one, we need to give it an x minus 3. And we're gonna do that on the top and the bottom. Now that matches that, you see what I'm saying? So now this one needs to match. So what does this one need?
X
Yep.
plus 3.
Yep. Top and bottom, make sure you're adding it to the top and the bottom. Right? Now, do all the denominators look the same?
Yep.
So forget them and look at the numerator. So I have an x minus 3. I have a 5, x plus 2, and I have a 25. Okay? All right, Sandra, what do I do now? What would you do? Yep, so x squared minus 3x. Do it over here too, 5x plus 10.
Combine like terms.
Combine like terms, so x squared plus 2x, if I add these together, plus 10 equals 25.
Move the 25, move
Move the 25, so x squared plus 2x minus 15.
then negative.
Now, hopefully it factors, but we just did one a minute ago. If it doesn't factor, we'll use the quadratic formula, right? Does this one factor?
Yes.
X
Plus, yep.
Plus 5 minus 3.
plus 5 minus 3. Because 5 times 3 is 15. So what are my answers? X equals?
Negative 5.
-5 or 3?
But let's check for sure.
Are we okay with both of those?
No.
No, which one isn't gonna work?
3.
3.
3 is not gonna work. Now, is it possible that we get no extraneous roots? Sure. Is it possible that we get 2 extraneous roots? Sure. You just gotta keep your eyes open for each problem. Okay? All right, so I just did the last one for you. That didn't take very long to probably finish this assignment.